is enhancing its nuclear arsenal. Earlier, it launched missiles into the South China Sea, and now it has powered its nuclear submarines with ballistic missiles that are capable of hitting the United States. In the high-stakes world of naval supremacy, submarines reign as crown jewels of any formidable fleet.
Supercavitation gets around that. It creates a bubble of air around the torpedo, so it's essentially moving through air and not water.
What if torpedoes could think for themselves? China has developed submarine-launched torpedoes powered by artificial intelligence, capable of learning, adapting, and tracking underwater targets, even through complex decoys. Unlike traditional torpedoes, which rely on pre-programmed routes or simple acoustic homing, these torpedoes use advanced neural networks to assess their environment in real time. They are designed to distinguish between actual submarines and decoys by recognizing subtle differences in acoustic signatures, vibration patterns, and movement behaviors. In recent tests, they achieved over 92% accuracy in identifying real submarines, marking a breakthrough in undersea technology. It is not simply reacting to a target. It's evaluating threats, determining optimal paths, and choosing engagement strategies, all without human input after launch. That autonomy is what makes this technology stand out. This video explores how these torpedoes work, why they're different, and what it means for naval defense. Their ability to differentiate between decoys and real targets introduces new challenges for defensive strategies traditionally employed by global navies. Their built-in processors interpret the acoustic environment by drawing on a vast library of known decoy signals and real submarine signatures. The torpedo's neural network assesses movement dynamics, acoustic frequency consistency, and even the timing of sonar pings. Instead of relying solely on hardware-based defense, navies may need to integrate real-time AI counterintelligence into their torpedoes and decoys. This might involve neural decoys that evolve their acoustic output or torpedo tracking systems that feed environmental updates to central shipboard processors. When a decoy emits inconsistent or overly mechanical signals, the AI adjusts and refocuses on more viable targets. The South China Sea, where Chinese naval activity is prominent, it is filled with shallow, noisy, and highly trafficked waters, an environment where conventional sonar struggles. When defensive tools lose reliability, commanders become more cautious. It turns reactive defense into a proactive challenge and forces adversaries to rethink how they manage risk under the waves. This affects mission planning, patrol routes, and geopolitical confidence. The Office of Naval Research is leading several exploratory programs, including autonomous underwater vehicles, AUVs, that may deploy AI-guided munitions. These systems are designed to mimic the learning behavior demonstrated in the Chinese model, though many remain in development stages. The U.S. Navy would need to adopt new rules of engagement that accommodate semi-autonomous weapons operating with limited human input. This carries operational and ethical considerations. Transitioning from legacy systems to AI-augmented tools requires secure software pipelines, low-latency decision frameworks, and rigorous simulation training. The ability to teach a torpedo how to think could be just as important as making it faster or more powerful, particularly in complex maritime zones. Reduced freedom of maneuver could lead to risk-averse behavior that reshapes regional presence. Still, no publicly disclosed system has achieved operational status comparable to what China claims to have tested. For torpedoes, that means thousands of hours of sonar recordings, environmental noise simulations, and classified acoustic profiles. The U.S. has an extensive database, but integrating that into real-time learning systems remains a technical hurdle. The integration of artificial intelligence into offensive torpedo systems is still developing. The most advanced torpedo currently in service is the Mk-48 Advanced Capability (ADCAP), which is equipped with sophisticated sonar guidance, a digital control system, and wire-guided mid-course updates. However, it does not feature adaptive AI-driven targeting or deep learning capabilities. In these environments, human-guided torpedoes can falter. China's AI-enabled torpedoes represent a leap in underwater systems intelligence, transforming how navies think about detection, defense, and strategy. This development isn't just about technology. It's about a shift in how decisions are made in the most concealed domain on Earth. As the algorithms evolve, the world's oceans may soon become home to the most advanced, autonomous systems humanity has ever built, and that changes everything. AI-powered torpedoes, with their constant environmental learning, are built for just this kind of complexity, such as towed sonar decoys or noise generation techniques, reducing the effectiveness of those traditional methods. They are designed to distract or confuse conventional torpedoes. Current countermeasure systems used on U.S. vessels. However, these new AI-guided models evaluate and learn. The PLA's reported progress indicates a shift from reactive to predictive engagement. China's torpedoes operate with a level of autonomy that current U.S. torpedoes lack. By relying on neural networks that evolve in real time, this isn't just about speed or power, it's about decision-making. This represents a broader shift toward autonomous undersea platforms that rely on artificial intelligence for both navigation and decision-making. As underwater battle space grows more congested and complex, AI-enabled torpedoes could soon set the standard for precision-guided maritime tools, including signatures from real submarines, simulated vessels, and known decoy tactics. Once launched, the torpedo processes sonar data, re-evaluates classifications. These vessels often operate in defensive formations with layers of sonar buoys, anti-submarine patrols, and evasive equipment. The problem is, all of those systems are built on assumptions that the threat is mechanical and predictable. With adaptive AI guidance, the threat becomes analytical. This could result in a munition that is both fast and agile while navigating complex underwater terrains, and adapts its course dynamically. In other words, it doesn't just detect, it interprets. Let's dive into a world where machines aren't just fired. They analyze, decide, and pursue, which allows it to travel inside a bubble of gas, reducing drag and enabling extremely high speeds. When combined with AI navigation, the smart torpedo era, China's new generation of AI-powered torpedoes, is changing the landscape of underwater technology. According to a peer-reviewed paper published in the Chinese journal China Ship Research, the AI torpedo was tested in over 300 simulated underwater combat environments. In these trials, it successfully identified and engaged the intended target in 92.2% of scenarios, even when presented with acoustic jamming and multi-layered countermeasures. This leap in targeting precision is due to a combination of deep learning algorithms and physics-based modeling that allows the torpedo to continuously analyze the sonar environment during pursuit. The system draws from an extensive data bank of underwater sounds. Adding to its capabilities, there are indications the torpedo may incorporate supercavitation propulsion. This type of smart guidance system shifts the role of the torpedo from a passive seeker to an active hunter. Arleigh Burke-class destroyers and Virginia-class submarines. The implications go beyond the weapon itself. The potential of China's AI-enabled torpedoes to alter maritime security dynamics is substantial. China is raising the bar for engagement complexity. In particular, these torpedoes excel at underwater pattern recognition. This presents a challenge for high-value naval assets like U.S. aircraft carriers. Experts suggest that this could lead to a new doctrine of submarine engagement. Moreover, there's the concern of operational space. This is aware of this shift and has begun investing in next-generation undersea weapons that emphasize artificial intelligence and machine learning. It's also worth noting the psychological and strategic ramifications. By introducing smart autonomy into undersea platforms, can the U.S. respond? While the U.S. leads in many domains of undersea technology, that gap is increasingly significant. Furthermore, DARPA's Manta Ray program seeks to create long-duration autonomous submersibles that could serve as mobile launch platforms for AI-based torpedoes. Another dimension of the U.S. response is data acquisition. Effective AI relies on training data. Beyond platforms and data, there is also the question of doctrine. If the goal is to match China's advancement, then integration speed will be key. The race isn't just about building better torpedoes. It's about redefining how decisions are made underwater. And in that race, we're no longer talking about simple underwater weapons. We're entering an era where machines analyze, decide, and pursue targets independently beneath the surface.